Welcome back to our finite element method tutorial series. In our previous session, we explored the shape functions for Q4 elements, an essential building block for quadrilateral meshes. Today, we are taking the next step. We will dive into the T6 element, a higher order triangular element that brings improved accuracy through quadratic interpolation. We will start by walking through the derivation of the shape functions by step, making sure the transition from Q4 to T6 feels logical. Whether you are a beginner building your FM foundation or a research student refining your mesh formulations, this video will guide you through the complete derivation of T6 shape functions using natural coordinates. So let's get started. So first of all, I will draw the T6 element in natural coordinate system. So this is my xy coordinate and this is the triangle for T6 element. So I will just mark this as node 1, this as node 2 and this point is node 3. So we have to be careful that the numbering should be in anti-clockwise direction. As this is a T6 element, so there should be total 6 nodes. The 3 nodes at each corner of this triangle and the remaining 3 will be at the midpoint of the edges. Here one, another one here and another one here. So I will numbering this also in anti-clockwise direction. This one is 4, this one is node number 5 and this is node 6. Let's write down the coordinate of each node. This one is 0 0. This one is r comma 0. This one is 0 comma s. This one is r by 2 0. This one is 0 s by 2. This one is r by 2 s by 2. To determine the shape functions for each node, I have to be careful here. Like for node 1, I have to take the equations of the lines which are not touching this point, but it should touch all the remaining points. So in that way, I have to take some imaginary lines here. Like I need the equation of this line. I also need the equation of this line and this line too. So first of all, I will write down the equations of those lines. For line 1 2 means this line, this is on x-axis, so the equation of this line will be y equal to 0. Okay, and for through the element 1 3, the equation of this line will be x equal to 0 as it is on y-axis. So this one is x equal to 0. For the line 2 3, the equation will be as the x intersection point is r comma 0 and y intersecting point is 0 comma s. So the equation of this line will be x by r plus y by s is equal to 1. Also, I need the equations of these three lines also. So, for the line 4, 5, the equation will be x equal to half. For 5, 6, the equation will be y equal to half. And for 4, 6 line, the equation will be x by r plus y by s equal to half. Oh, sorry, this one will be x equal to r by 2. This one will be x equal to r by 2, and this one will be y equal to s by 2. So I have all the equations of those lines. Now coming to the derivation of shape functions. For n1, for this point, for the node 1, this point, I have to make the shape functions in such a way that in other nodes it should be 0. So how I will take this? So I have to take the equation of this line and the equation of this line. So these two equations will give, means these two equations will touch all the remaining 5 points except this one, point 1. So how I will write the shape functions? Like previously for Q4 I have written n1 equal to some constant c1 into equations of these two lines. So equation of line 4, 6 and equation of line 2, 3. What are those? Let's see. That one of those is x by r plus y by s minus 1, and other one is x by r plus y by s minus half. So the shape function at node 1 it would be 1. So using that boundary condition I can get the value of c1. So let's do that. So 1 equal to c1, x is 0, y is 0, so this would be minus 1, this would be minus 1. So from here I am getting c1 equal to 2. Now I will just write down the shape function n1. So here n1 would be 2 into x by r plus y by s minus 1 and x by r plus y by s minus half. I will just take the 2 inside, so it would be x by r plus y by s minus 1 and 2x by r plus 2y by s minus 1. So this is the shape functions for node 1. Now we will go to this node 2. So for node 2, which equation I should take, by which I will get those equations in such a way that all the remaining points should touch? That one is this 1, 3 line, other one is 4, 5 line. So let's write down the equations of those two lines. So n2 equal to 1 constant c2 and the equations of line 1 3, that is x equal to 0, and the equations of 4 5, that is x equal to r by 2. One is x equal to 0, so it would be simply x, and other one is x equal to r by 2. And what is the coordinate of point 2? That is r0. So at r0 point, the value of n2 should be 1. From there we can calculate the value of this c2. So x value is here r by 2. Sorry, at 2 the value is r. So r into r minus r by 2. So from here we will get c2 equal to 2 by r square. Yeah, r minus r by 2 is r by 2. So r square by 2, 2 by r square. Yeah. So n2 will be 2 by r square x into x minus r by 2. Just rearrange those. So it would be n2 equal to 2 into x by r into uh, let's take the 2 inside. So it would be x by r into 2x by r minus 1. Let's check once again. That is x by r, and 2 by r I took inside. So it would be 2x by r minus 1. So fine. So also I got the shape functions for node 2 this. So if we look carefully for node 2 and node 3, this is node 2 at x-axis and node 3 at y-axis in similar way. So just if we change the x with y and r with s, we will get the shape functions for node number 3. So we can directly write that, or else we can calculate in the similar way, and from above analysis we can write that the shape functions for n3 would be y by s into 2y by s minus 1. It is the pen problem. Just a minute. Yeah, sorry for this. So in the same way I got the value for n3. Now coming to node 4. Node 4 is here. So for the remaining point, I should take the equations of this 1 3 line that touches point 0.6 and this 2 3 line that touches point 0.5. So by using these two lines equation, I can get the shape functions for node 4. So let's write down. So n4 equal to the constant I am taking c4, and the equations of those lines will be, one is for 1 3, other one is 2 3. 1 3 equations is x equal to 0 and 2 3 equations is x by r plus y by s equal to 1. So one is x equal to 0, other one is x by r plus y by s equal to 1, that is minus 1. And what is the location of node 4? That is r by 2 0. So at r by 2 0 location, n4 will be 1. So n4 is 1 at location r by 2 0. This one is c4. So the value of c4 would be, let's write down another line, r by 2, r will get cancelled and this one will be minus half. So c4 is minus 4 by r. So the shape function will be n4 equal to minus 4 by r x, x by r plus y by s minus 1. So let's write down in a general form, that is 4 x by r 1 minus x by r minus y by s. So this is the shape function for node 4. So similarly, as I did the shape functions for n3 from n2, similarly for n6 the same thing I can do from the value of 4. So I will just replace x with y, y with x, r with s and s with r. So similarly the n5 will be 4 y by s 1 minus y by s minus x by r. Or I can do the same calculation for n5. Sorry, this one is not n5, this one is n6. Now coming to the n5. So n5 is at these locations. To get the shape functions for this point, I will take just this line and this line equation. So one is x equal to 0, other one is y equal to 0. So n5 is just simply c5 c5 xy. So the location of this node 5 is r by 2 s by 2, that point n5 value will be 1. So I will get the value of s5 from c5 from there, that is 4 by rs. So I can write down the shift functions n5 equal to 4 by rs xy. So n5 is 4 into x by r y by s. So these all are the shift functions for T6 element. So let's just write down all together. So n1 we got x by r plus y by s minus 1 into 2x by r plus 2y by s minus 1. So x by r plus y by s minus 1 and 2x by r plus 2y by s minus 1. Into we got x by r into 2x by r minus 1, x by r into 2x by r minus 1. N3 is y by s into 2y by s minus 1. N4 we got, that is 4x by r into 1 minus x by r minus y by s. N5 is 4 into x by r y by s, and finally the n6 value is 4 into y by s into 1 minus y by s minus x by r. So I have derived all the shape functions for this T6 element. In the next video we will start with Q8 elements. So bye.